Today, we're diving into a real-life medical detective story. We're on the case of a rare, aggressive bone cancer called Ewing sarcoma that mostly affects kids and teenagers. Together, we're going to follow the clues from the very first symptoms all the way to the smoking gun that's hidden deep inside our DNA.
So where does the case begin? Well, it almost always starts with something that feels pretty ordinary. A throbbing pain in a long bone, like an arm or a leg, maybe some swelling. It's exactly the kind of ache that's so easy to just brush off at first.
And that right there, that's the big question that kicks off this whole investigation. Because when that pain just refuses to go away, and when other weird signs start popping up, doctors know they need to start looking for a totally different explanation. This is where the real detective work begins.
All right, first things first. We need to build a profile of our suspect. What exactly is this mysterious bone pain, and who does it typically target?
Okay, here's the initial rap sheet. Ewing sarcoma is a seriously malignant tumor that gets its start right inside the bone marrow. It usually goes after kids and teens, mostly between 10 and 15, and its favorite hiding spot is the main shaft of the femur. But here's the kicker. What makes it so tough to pin down early on? It's a master of disguise. With symptoms like fever and warmth, it can look almost exactly like a common bone infection, sending the first part of the investigation way off track.
So once the physical exam and the patient's story start raising some red flags, the investigation moves into the lab. We need hard evidence, right? And the first place to look is at the imaging and at the cells themselves. Now this is one of the most famous signs in this field. On an X-ray, the bone can actually show these layers of new bone growth, and it looks just like the layers of an onion. It happens because the tumor underneath is irritating the lining of the bone, causing it to build up these thin new layers. It's not a foolproof sign, but it's a very strong clue that points investigators in the right direction.
So the next crucial step is what pathologists see when they get a biopsy under the microscope. They find a sea of small, round, blue-looking cells. And here's a key piece of evidence. These cells are absolutely packed with a sugar called glycogen. To prove it, they use a special stain that turns the glycogen bright magenta. Then, for the final confirmation, they use an enzyme that just washes that sugar away. If the bright color disappears with it, they know they're on the right trail.
Now, this gets a little bit technical, but stick with me because it's important. Ewing's is part of a bigger family of tumors called peanuts. Think of it this way. Peanut cells look like they're trying to become nerve cells. They're starting to show some specialized features. The Ewing sarcoma cells, on the other hand, are way more primitive. They haven't really decided what they want to be yet. But even with those differences, they all share a critical family secret.
And this brings us to the aha moment of the entire investigation. All the clues we've gathered so far, they're circumstantial. Now we're getting into the hard forensic evidence, the DNA fingerprint that gives us definitive proof. Just let that number sink in for a second. In 80 to 95% of these cases, this one specific genetic marker is there. This isn't just another clue, it's practically a confession. This is the smoking gun that confirms the identity of Ewing sarcoma, without a doubt.
So what is this smoking gun? It's a very specific mistake in the tumor's genetic code called a chromosome translocation. Imagine you've got two different instruction manuals, chromosome 11 and chromosome 22. A translocation is like a chapter from manual 11 gets ripped out and accidentally taped into manual 22. This particular swap, which we call T1122, is the absolute defining feature of the entire Ewing's tumor family.
And the result of that genetic page swap? It creates a brand new, faulty instruction that tells the cell to make a massive amount of a protein called CD99. Pathologists can then use a stain that specifically lights up this protein on the cell surface. It's the final fingerprint that helps separate Ewing's from other look-alike tumors and totally clinches the diagnosis. Case closed.
Okay, so with our culprit positively identified, the focus makes a huge shift. We're moving from investigation to action, and fighting Ewing's sarcoma requires a really coordinated, multi-front attack.
The standard game plan is a super logical, three-step process. First, doctors hit it with neoadjuvant chemotherapy. That's chemo given before surgery. The goal is to shrink the tumor and make it easier to remove. Step 2 is the surgery itself, getting that primary tumor out of there. And finally, they follow up with post-operative chemo to hunt down and wipe out any stray cancer cells that might be hiding somewhere else in the body.
There's this really memorable quote used to describe how this tumor responds to another treatment, radiation. It is highly radiosensitive, so much so that people say it melts like snow under radiation therapy. But, and this is a big but, the source material is very clear that if you only use radiation, there's a really high chance the tumor will come back. So it's a powerful tool, but it's almost always used as part of a bigger plan.
So even when you have a clear battle plan, every single case is different. What are the key factors that help doctors predict the outcome and get a sense of the patient's future?
So let's break this down. A few key things really influence the outlook. The single biggest factor, the toughest challenge, is whether the cancer is already spread to other parts of the body at the time of diagnosis. Location also plays a huge role. Tumors in the center of the body, like in the pelvis, are just plain harder to treat than ones in an arm or a leg. The presence of symptoms like a fever suggests the disease is more aggressive. And finally, statistics show that being older or male when you're diagnosed is also linked with a poorer prognosis.
And that brings